Sequences can either be arithmetic or geometric. Let's look at an arithmetic sequence. This was one of the examples that was given. And this is an arithmetic sequence. In an arithmetic sequence, you will add a positive or negative number to get to the next term. That means the pairs of successive terms have a common difference, which we call D. This means that no matter which two terms you pick that are consecutive, that are next to each other, they will always have a difference of D. And in this example, 15 minus 10 is 5. 20 minus 15 is 5. 25 minus 20 is 5. No matter which two successive terms you pick, if you subtract them, the difference will always be the same, 5 in this case. Sequences can be written in either explicitly or recursively. So if we were to look at a sequence, an arithmetic sequence, as an explicit or written explicitly, then we would say we have term 1, so a sub 1 is term 1. Then we have the next term, a sub 1 plus d, the common difference. Then we would have a sub 1 plus 2d, a sub 1 plus 3d, and so on, till we had all of our terms, which can always be written as a sub 1 plus our common difference d times n minus 1. Okay, and it's always n minus 1 because our first term, we're not adding anything to get it. We have our first term, and in our second term, we add d once. For our third term, we add d twice. So we're always adding d one less than the term number we're on. If we were looking at an arithmetic sequence defined recursively, then it would look like a sub 1 equals whatever number is our first term. In this case, it would be 5. And then our next term, a sub n, is our previous term, a sub n minus 1, plus d. So in our example, 5, 10, 15, 20, and 25, a sub 1 would equal 5. And then to get our next term, we would take the previous term, a sub n minus 1, and we would add 5 because that's what our common difference is. It just happened that our common difference and our first term were the same. That's not always the case. So if we take a look at two sequences that are given, we need to determine which of them is arithmetic. So we ask ourselves, in which sequence do we take each term and just keep adding the same number, whether we're adding a positive or a negative, every time to get the next term? So if we look at sequence A from negative 5 to 2, we are adding 7. From 2 to 9, adding 7. 9 to 16, adding 7. All the way through, we are adding 7. So it looks like A is arithmetic. Okay, and I just checked each term and to see if we were adding the same number, and we were adding 7 each time. So that means our common difference is 7, but I could have actually done 16 minus 9 is 7, 9 minus 2 is 7, 2 minus negative 5 is 7, 23 minus 16. I could take the successive terms and subtract to find the common difference. So if I were to check B, if I were to see if there was a common difference, 3 minus 6 is negative 3, 6 minus 12 is negative 6, they're not the same. Or 48 plus what is 24, that'd be 48 plus negative 24, but if I tried it in the next one, it doesn't work, so it's not arithmetic. So let's use sequence A, which was -5, 2, 9, 16, and 23. And let's say what the common difference was. Well, we already found the common difference was 7. And again, 23 minus 16 is 7. 16 minus 9 is 7, and so on. All right, now we need to find the 10th term. So one thing we could do, since the 10th term is not that far off, we already have terms 1, 2, 3, 4, and 5, is we could just keep adding 7 until we get to the 10th term. Okay, that's completely fine. Or we could find the explicit rule for the nth term, and then we could just plug in 10 and find our answer. So let's hop down here to the bottom. A sub n equals, to find our explicit rule, well, we start with our first term, and then every time we were adding 7 times, how many times did we do it? Well, we always did it n minus 1 times, whatever term we were on, minus 1. And we can leave it like that, or we can simplify. And we can write 7n minus 12, but either way is fine. So either here or here. No matter which way we look at it, if we're finding the 10th term, a sub 10, -5 plus 7 times 10 minus 1, which is 9, this ended up giving you that 58 was the 10th term. If we have to find the recursive rule or the recursive equation, then we start with our first term, which is -5, and then after that, we find each additional term by taking the previous term and adding 7 every time.